brought to you by Thomas Allgaier and Frennis. This edition highlights key LinkedIn posts on next-gen vehicle intelligence in weeks 25 and 26. Frennis supports Tier 1 automotive suppliers with early-stage market validation for their R&D efforts by combining secondary research, direct OEM expert interviews, and facilitated customer meetings. You can find more info in the description.
Imagine spending $4 billion just to fix old computer code. Literally $4 billion, while your biggest competitor spends exactly zero.
Wow, yeah, zero. Welcome to our latest deep dive. Today, we are looking at why legacy automakers are just bleeding cash right now, and, well, why that whole idea of the smartphone on wheels is actually already an outdated concept.
Right, it's completely outdated. So if you're listening to this, we're basically unpacking a massive wave of insights that we've curated directly from the mobility industry's leading professionals on LinkedIn. This is all from calendar weeks 25 and 26.
Yeah, and if there is one overarching narrative you really need to take away from this deep dive, it's that the industry is undergoing a violent strategic shift. I mean, we are moving away from the software-defined vehicle, the SDV, and we are rapidly entering the era of the AI-defined vehicle, or ADV.
But the twist here is that the real battleground isn't actually the artificial intelligence itself.
Right.
It's the plumbing underneath. It's, the underlying architecture, the speed of execution across these massive supply chains, and this terrifying new challenge of how you mathematically validate these highly complex systems before they go on a public road.
Exactly. So let's start with that strategic shift because, for a solid decade now, the whole industry has practically been living and breathing the term software-defined vehicle.
Yeah, SDV was everything.
Right. And to give some context on how we got here, there was this brilliant breakdown circulating from Aladdin Hamdi. He laid out the evolution perfectly. First, the industry had to build a foundation, right? That was AUTOSAR.
Which basically standardized the messy background code.
Yeah, exactly. So different parts of a car could just speak a common language. And then came the SDV, which gave automakers flexibility. It fundamentally decoupled the physical hardware from the software, meaning you could update your car's infotainment over the air without, changing a physical chip.
And that decoupling was revolutionary at the time, but it was still just software following strict pre-written rules.
Yeah.
What Aladdin points out is that the AD, the AI-defined vehicle, brings active intelligence.
Yeah, and we have to be really precise about what that intelligence actually does.
Totally. Following that thread, Amrit Goenka and Kim Darling Sørensen added some crucial context. They noted that the ADV isn't just about using algorithms to control the steering or the brakes.
Right.
It fundamentally shapes the experience of being inside the machine. AI is becoming a core architectural layer of the car itself. It's not just some flashy voice assistant bolted onto the digital cockpit,
It's the central nervous system. Yeah. I have to push back a little here, though, because if you've been around the mobility space long enough, this sounds incredibly familiar.
Oh, sure.
Isn't this just the latest round of industry marketing hype? We spent years being promised this magical smartphone on wheels, and now suddenly the buzzword has shifted to an active personal assistant on wheels. But, look at legacy OEMs. Are they actually ready to build something that integrated?
Well, that is the exact tension causing sleepless nights in Detroit, Stuttgart, and Tokyo right now. ADAC Ernesto Aguilar addressed this beautifully in his takeaways from the ECV Auto Events Summit.
Oh, yeah, I saw that.
Yeah, he made it clear that AI is shifting from being just a consumer feature to a defining property of the vehicle architecture. The challenge for these traditional automakers isn't whether they have access to good AI models.
Right, they can just buy those.
Exactly. The challenge is how to scale that intelligence safely and deterministically across the entire vehicle. And that reality naturally exposes why current legacy architectures are just actively failing.
Which means if you successfully build a genius-level AI brain, it doesn't matter if the car's nervous system is a fragmented mess, right? The AI literally can't do its job.
Precisely. The dream of the AI-defined vehicle crashes incredibly hard into the reality of legacy automotive architecture. Kat Gann made a phenomenal observation about this contradiction.
What did she say?
Well, she pointed out that Western OEMs have access to the exact same frontier AI models as anyone else in the world. They can license the best tech out there. But what happens when they actually deploy them? They end up caging those advanced models inside what she calls chatterbox infotainment systems.
Chatterbox. Wow, that's a great word for it.
Right. You get a really smart screen in the dashboard, but it has no deep control over the car itself.
Because the underlying hardware just won't allow it.
Exactly. Legacy cars rely on dozens, sometimes like nearly 100 disjointed electronic control units, or ECUs. These are basically tiny, isolated computers scattered throughout the car.
So the ECU controlling the power windows has no idea what the ECU controlling the steering wheel is doing.
Yeah, they are physically and digitally siloed.
Yeah.
Meanwhile, if you look at companies like Tesla and the rising Chinese OEMs, they are treating the entire vehicle as a unified robot with a single, unified perception layer.
It's like having a genius brain hooked up to a body where the left hand can't communicate with the right foot.
Yeah, exactly.
And the financial cost of that disjointed approach is staggering. Going back to that $4 billion statistic from the top of the show, Satyabrata Pradhan shared an example that completely blew my mind.
It's a crazy number.
Right. In 2024, a major legacy OEM had to spend $4 billion just to fix software they originally wrote back in 2018. Over that same period, for that specific type of foundational software remediation, Tesla spent $0.
Zero.
Pradhan argues this isn't just a technical glitch, this is a profound identity shift. Legacy brands are still acting like hardware companies that just happen to have a software team bolted on as an afterthought.
It is a complete identity crisis. And honestly, it's driven heavily by the finance department, not just the engineering department. Thomas M. had a brilliant critique on this exact dynamic.
Oh, about the hardware decisions.
Yeah, he argued that the real killer of the software-defined vehicle in the West wasn't bad software. It was a hardware decision heavily disguised as a finance decision. Historically, Western OEMs decided to gate their hardware by trim levels to protect their profit margins.
Wait, so you mean by only putting the premium sensors and the high-performance computing power in the expensive luxury packages?
Exactly. If you only put the best cameras and radar on the $80,000 luxury SUV and leave them off the $30,000 base model, you protect your margin on the luxury car.
Right.
But by doing that, you completely kill your fleet-wide data flywheel. To train these advanced AI models, you need massive volume. You need data from every type of road, every type of weather, every type of driver. By gating the hardware, Western OEMs actively starved their own AI of the data it needed to learn.
Wow. Meanwhile, while they were protecting margins, companies like BYD and Tesla were shipping their full sensing stack to almost every single car rolling off the assembly line.
Yes. They effectively turned millions of their everyday drivers into an unpaid data flywheel, just constantly feeding raw, real-world data back to their central AI. And as Thomas M. pointed out, you cannot just license a data flywheel that you never took the time to build yourself.
That makes so much sense. Let me play devil's advocate for a second, though, because re-architecting an entire vehicle lineup to have a centralized brain is incredibly expensive.
Oh, absolutely.
Aniruddha Dorle, or Ani, jumped into this conversation with a really pragmatic counterpoint. He argued that moving away from those tiny isolated ECUs to a highly centralized zonal architecture where computation is grouped by the physical zones of the car rather than individual functions, well, it only makes sense if the economics actually justify it.
Right. The economics have to work.
You can't just force an ultra-expensive high-performance computing chip into a basic entry-level hatchback where a $3 microcontroller does the job of rolling down the window perfectly fine. The wiring, the variant management, and the assembly economics all have to align.
That is a very fair point, and it really highlights the friction between the theoretical ideal of an AI-driven car and the gritty industrial reality of mass manufacturing. But here's the catch. Whether you are building a $100,000 premium robotaxi or a smart $30,000 hatchback,
Right.
When things go wrong in these new interconnected architectures, diagnosing them is a total nightmare.
Oh, I bet.
Pravinder Singh pointed out that we are entering an era of what he calls vehicle triage.
Vehicle triage. So if you're an engineer trying to debug a problem, you're no longer just looking for a broken physical wire.
No, you are hunting down a ghost in a massive digital network. When an issue spans the cloud, the internal connectivity gateways, the vehicle networks, and the physical ECUs all at once, the new superpower for automotive engineers isn't just fixing a localized bug. It's the ability to trace end-to-end data flows across an incredibly complex, distributed system.
So if you successfully centralize the vehicle's architecture and give it this single, incredibly complex AI brain, you suddenly create a terrifying new problem.
Yeah, a single point of failure.
Right. If that single brain fails or gets confused, the whole car goes down. So how do you mathematically prove a system like that is actually safe to put on the highway at 70 miles an hour?
That is the existential question right now. Because the old methods of validating safety simply do not scale to artificial intelligence. Thananthan Sozane introduced a concept into the discussion that he calls the validation paradox.
The validation paradox. Okay.
Yeah, for decades, the industry's approach to safety was mileage accumulation. You just drive the car for millions of miles on test tracks and highways. But with AI and autonomous systems, the number of possible scenarios the vehicle might encounter, combinations of weird weather, unpredictable traffic, strange human behavior, is functionally infinite.
You literally cannot drive enough miles to prove it's safe.
Exactly. So the entire industry is shifting away from mileage accumulation towards scenario-based testing. They are hunting for the critical edge cases that actually matter most.
It's like trying to train a new teenage driver by making them drive on a completely empty, straight highway for 10 straight years. Sure, they log a lot of miles, but they learn absolutely nothing about how to handle a real emergency.
Right, they'd panic the first time someone slams on the brakes.
Exactly. Scenario-based testing is like putting that teenager in a simulator where a deer jumps out on an icy road every 5 minutes. You are identifying and practicing the exact trick questions that are going to appear on the real-world exam.
That is a much better way to think about it. You have to focus entirely on those edge cases. But the complexity doesn't stop there. Even when you find those edge cases and train the AI to recognize them, the way the vehicle's internal network responds has to be flawless on a physical level. Fadi Labib made a fascinating comparison between modern cloud computing systems and autonomous automotive systems.
Oh.
Well, on paper, they actually use very similar digital communication patterns.
Yeah.
Things like request and response or publish and subscribe architectures.
But the stakes are completely different.
Entirely different. In a cloud architecture, if a server drops a message or there's a slight network delay, you might get a 500 error on a web page. Or you're streaming video buffers for a second. You just refresh the page.
No big deal.
Right. In a car, you're dealing with hard real-time deadlines. If a publish command for the automatic emergency braking system drops a packet or arrives 50 milliseconds too late, you have a life-threatening safety hazard.
Wow, 50 milliseconds.
Yeah, you have what engineers call worst-case execution times that must be mathematically guaranteed. You cannot simply copy and paste an Amazon Web Services architecture into a vehicle's braking system because the mathematical models for safety simply don't transfer.
And speaking of the mathematics of safety, we have to talk about how the industry actually classifies that risk. Because it's not as simple as asking, did the camera break? Imran Khan posted a really sharp take on the ISO 26262 standard and the ASIL framework that stands for Automotive Safety Integrity Level for anyone taking notes.
Right, ASIL.
He stressed that ASIL is not just a hardware label that you print on a box and slap onto a component. It is a vehicle-level risk judgment.
This is a crucial distinction. A sensor failing isn't actually the hazard. The hazard is the unintended vehicle motion that happens because of that failure in a highly specific driving scenario. It's about how the entire centralized system reacts to the absence of that sensor data.
And that vehicle-level risk doesn't just apply to the pristine factory floor. It extends all the way into the messy reality of aftermarket repair shops.
Oh yeah, the aftermarket is a whole other beast.
Frank Turlip shared some staggering reality checks from the collision and repair industry that really ground all this high-level engineering into everyday consumer reality. He noted that ADAS calibrations, advanced driver assistance systems calibrations, appeared on nearly 35% of all repair estimates in 2025.
Wow. Over a third.
Yeah, and that is adding an average of $688 to the repair bill.
It's a massive hidden cost of this intelligence. But Frank highlights a much deeper critical insight. The gap between a shop doing a calibration and actually validating that it was done correctly is becoming a massive liability issue.
Because it's so complex now.
Exactly. Subletting this calibration work to third parties is incredibly common right now because of the vast array of specialized sensors involved. And that makes accountability very fuzzy. A calibration on an AI-defined vehicle is no longer just a checkbox on an invoice. It is a critical safety validating procedure. If an independent shop gets it wrong, the car's centralized brain operates on bad data.
So if you step back and look at the whole picture, we've got cars transforming into highly centralized AI-driven robots. We have massive internal architecture overhauls causing identity crises at legacy automakers, and we have these mind-bending safety validation challenges.
That's a lot.
It is. So how is all of this actually playing out competitively on the global stage? Because whoever solves this first owns the future of mobility. If you look at what people like Scott Newton are tracking, there is a tectonic geographic shift happening. He recently pointed out that Chinese automakers, specifically brands like BYD and MG, are rapidly overtaking traditional German OEMs right in their own core European markets.
It is a fundamental rewiring of the industry landscape.
Yeah.
And it all comes back to how you manage that complexity we just talked about. Yuma provided a brilliant, detailed breakdown of exactly how BYD is achieving this dominance.
Vertical integration, right?
Exactly. Ruthless vertical integration. BYD has over 3.1 million intelligent vehicles currently on the road, generating 200 million kilometers of driving data every single day. But more importantly, they aren't just assembling parts bought from 100 different suppliers. They control the battery chemistry. They manufacture the power semiconductors. They write the software. They train the AI algorithms, and they own the data loop.
They own the entire stack, which solves the exact problem Kat Gann pointed out earlier about legacy OEMs having dozens of disjointed ECUs built by different suppliers that refuse to talk to each other. If you own the whole stack, you can force the system to be unified.
Precisely. And it's not just the technology that is moving fast. The regulatory landscape is surprisingly keeping pace, which is acting as a massive enabler for this global race.
Right.
Ian Richards and Raul Latour-Fortes posted some great insights about the UNWP.29 global framework. The United Nations essentially just agreed on the world's first unified global regulatory framework for homologating fully driverless vehicles.
So the legal roadblocks are actually being cleared at the international level, and you see it at the national level too. Paul Comfort noted that in the U.S., regulators are actively proposing to drop the long-standing safety standards that require manual steering wheels and brake pedals entirely for autonomous vehicles.
The regulatory momentum is definitely there, but we do need to temper some of this futuristic excitement with a dose of industrial reality, because the gap between a cutting-edge prototype and what you can actually buy is still huge.
Yeah, that's fair.
Maite Alves-Becerra, speaking at the Infineon Automotive Ecosystem Summit, provided a very sobering reality check. Despite all the hype and the billions of dollars surrounding SDVs and AI, she noted that 90% of new vehicles sold in 2026 will still not be true software-defined vehicles.
Wait, 90%? So the vast majority of cars hitting the dealership lots this year are still running on those legacy fragmented architectures.
Exactly. And Joachim Langenwalter's takeaway from the Automobile Electronic Congress AEK 2026 really drives home why that gap exists. He observed that technology itself is no longer the bottleneck in the automotive industry. Everyone has access to the high-performance computing chips. Everyone has access to frontier AI code.
So what's holding them back?
The real bottleneck is execution and ecosystem collaboration. Scaling these next-generation AI vehicles requires an orchestrated ecosystem of silicon, software, tooling, and cloud infrastructure working together seamlessly. The days of a single automaker doing everything in isolation or just acting as a passive systems integrator are over.
Which perfectly brings us to a really provocative thought to leave you with, because this evolution from disjointed hardware to a centralized AI brain fundamentally changes your relationship with the car itself. There's a post from John Schneibel that really got me thinking about the ongoing right to repair debate.
Oh, that's a crucial angle. The technical architecture always dictates the legal reality.
Right. Schneibel pointed out that restrictions on independent repair shops have been around since the 1990s. This was way before anyone in the industry was actively worried about digital hackers or cybersecurity. It's historically always been about controlling ownership and access to proprietary information.
Sure.
But as we move into this new era where vehicles are highly centralized, AI-defined robots, things get infinitely more complicated. How will the very definition of car ownership fundamentally change when your local independent mechanic has to interface with an OEM's proprietary, cloud-connected central intelligence layer just to, replace a physical brake actuator or calibrate a bumper sensor?
It's a profound question to leave on. If the vehicle's intelligence, and therefore its ability to even function safely, is locked behind a centralized AI architecture owned by the manufacturer, do you really own the car sitting in your driveway? Or are you essentially just licensing a piece of hardware that the OEM controls?
Brought to you by Thomas Allgaier and Frennis. This edition highlights key LinkedIn posts on next-gen vehicle intelligence in weeks 25 and 26. Frennis supports Tier 1 automotive suppliers with early-stage market validation for their R&D efforts by combining secondary research, direct OEM expert interviews, and facilitated customer meetings. You can find more info in the description. If you enjoyed this episode, new episodes drop every 2 weeks. Also, check out our other editions on electrification and battery technology, future mobility and market evolution, and commercial fleet insights.
Thank you so much for joining us on this deep dive. Don't forget to subscribe so you never miss an update on where the mobility industry is heading next.
Until next time, keep your eyes on the road and your architecture centralized.